So friends, welcome to lecture 13 of the course on advanced steel design. In this lecture, we are going to learn more about the partial factors. So this lecture is also focusing on design methods. In the last lecture, we said that gamma f into Sp should be less than or equal to gamma p divided by gamma m. Okay. So we call this as the design load and we call this as the design strength. Whereas the factors address the uncertainties which are arising from various sources as we discussed in the last lecture. So having said that the factors present in the load and the strength are going to take care of these uncertainties, they are anyway addressed only as partial factors. So let us take for example the load factor, which is gamma f. In the literature, gamma f is actually a product of gamma f1, gamma f2, gamma f3. So it has got three subdivisions. Let us see what are these three subdivisions address. Gamma f1 accounts for load deviation from the assigned characteristic value. If we say the characteristic value is 5%, the exceedance is only allowed 5%. But if it exceeds beyond 5%, what is that exceedance beyond the characteristic value will be looked at gamma f1 separately. Gamma f2 will account for reduced probability that several independent loads appear together with the same characteristic value. When several loads with the same characteristic value appear together, there can be a reduced probability of that combination. So gamma f2 looks for that. Gamma f3 accounts for possibility of inaccuracy. In the load value arising from mathematical error or mathematical model error, variation from the real problem, problem arising during erection or construction, etc. So amongst these, if you look at carefully, gamma f2 addresses the effect of load combination, is it not? So even within the partial safety factor of load itself, there are three sub classifications. Similarly, if you look at gamma m, This accounts for possibility of unfavorable deviations of yield strength of the material from its characteristic value. There can be factors arising from local weakening of the section due to or during erection. There can be difference in the material strength, for example sigma u in the lab and that observed in the field. So, in the field also you conduct experiments, you find out ultimate strength and Young's modulus in the field, can compare those data directly with the manufactured supplier's data. So, there can be a variation and that difference is accounted in gamma m. Further, there can be dimensional inaccuracy which can arise during erection. There can be also error in mathematical modeling of the material. Okay. However, many codes do not distinguish these factors elaborately and do not give the percentage contribution of gamma m or gamma f from independent factors. They give a single combined number. Okay. So, for example, if gamma f is 1.5 and gamma m is 1.15 as in Indian codes, you will not come to know this 1.5 will be contribution from various sources. What is the effect of every factor on this gamma m? You will not know these independent contributions. Okay, but they are together contributing to gamma m. We can only know that. Let us now see something called load effects. See, what is a load effect? Based on the effects caused by the loads on structures, loads can be categorized. As P class load, L class load, D class load, E class load and A class load. P class refers to permanent load, L class refers to live load, D class refers to deformation load, E class refers to environmental load and A class refers to accidental load. Let us see them slightly elaborate. P class load, which are permanent load, they include time dependent loads. Examples could be gravity load, weight of any permanent machinery on the structure, and their variation over a period of time. So, the good thing about this class of load is this class of load is generally estimated with higher degree of accuracy. Hence, the characteristic value of P class load is generally taken as an average of the data available. Okay? And we can compute this with higher accuracy. Let us come to L class load. L class load anywhere refers to live load. Live load are associated with nature and operational features of the structure. That is why they are called live load. So, now the choice of the characteristic value depends on type of the structure, not on the type of the load, friends. When we talk about D class loads, which refer to deformation loads, these loads are imposing, they impose deformation on the members. It may be due to temperature effect, due to differential settlement, due to settlement of supports, due to form dominance nature of the structure. So, the characteristic value of D class is prescribed as the maximum expected values. Okay, it is an upper limit. If you come to the E class load, which refers to environmental load, they are associated with loads arising from the environment. Examples could be wave load, wind load, load arising from current, earthquake load, etc. They are generally classified with the help of a term called mean return period. Mean return period is defined as the expected number of years between a seasonal maximum to occur. For example, if the return period is 50 years, it means that the characteristic load is expected to occur only once in 50 years. That is the return period. Now, inverse of the return period is a very interesting parameter. This is the probability that the characteristic value will be exceeded in any 1 year of its application. For example, if the return period of wind load is 100 years, inverse of this is going to be 0.01. So, we can now say that probability of the wind load, that is the characteristic value, okay, will be exceeded in any 1 year is 0.01, which is nothing but 1 by 100. So, 99% it will not exceed, okay, in any 1 year, but 1% there is a probability it may exceed, okay. That is what the meaning of inverse return period. Now, friends, we have the return period which is expressed for the environmental loads. We have seen the inverse of the return period also. Now, we have seen that return period and its probability of exceedance in 1 year. Now, what the question we want to know is, what is the probability that the characteristic load will be exceeded during the lifetime of the structure? What is the probability? So, now since 1 by R is the probability of that load exceeding in 1 year, 1 minus 1 by R will the probability of non-exceedance in 1 year, is it not? So, the probability of non-exceedance of the load in 1 year is 1 minus 1 by R. What is the probability of non-exceedance in n years? Will be 1 minus 1 by R to the power n. Now, we are looking for what is the probability of exceedance of the characteristic load in n years. So, I should say probability of exceedance in n years 1 minus 1 by R to the power n, right. For example, if the return period is 50 years and the lifetime of the structure is 20 years, we can now say the probability of design load exceeding at least once during the service life, that is 20 years of the structure, could be P20, which is 1 minus 1 by r to the power n 1 minus 1 by 50 to the power 20. So, it has got an exceedance of 33%, which is an alarming number, is it not? It is an alarming number. So, it is interestingly, friends, the return period is 50 years, service life is only 20, you may possibly think the exceedance will not happen at all. See here, it is about 33%. So, it is clear from the example that there is a chance of design load exceeding at least once in the service life is about 33%, which is an alarming number. Therefore, safety factors are important. Okay. The last one is an accident class loads. A class load refers to accident class. These loads are exceptional cases. They arise when there is a collision, when there is an explosion or fire, or there can be accidents caused due to dropped objects. Now, the characteristic load of the dropped objects or accidental load of this class depends on the subject of investigation and operational manner, etc. So, friends, in this lecture we have discussed about different class of loads. We have discussed about return period. We have discussed about the probability of exceedance of the return period, and we have seen how the return period is connected to service life of the structure. So, please revise these concepts and take many examples from the textbook, try to look into them, read research papers from various journals in this connection, and update your knowledge and know-how on these fronts. Thank you very much. Have a good day.